Hello Geometry, welcome to 3.1, Identifying Pairs of Lines and Angles. Today is a very, very rainy Labor Day, so hopefully you're doing something constructive at home. Here we go. Let's start off with, I can identify. So basically, we're looking at a little bit more vocabulary here, so these are not big items that we're going to be taking care of today. So proofs are coming shortly though. So I can identify lines and planes, I can identify parallel and perpendicular lines, and I can identify pairs of angles. This is the really big one. We need to know this vocabulary, formed by transversals. All right, so here we go. Let's do our warm-up. Use the diagram to answer the following. Name a line that does not intersect AD. Okay, so I'm going to kind of color that, let's color it in blue so it stands out. Here's AD. We need a line that does not intersect AD. Well, how about this one? CB. CB is also, well, that's a dot, I was going to say. You can use IF or IC, any of those choices. What is the intersection of AD, right here, and DB? Now, don't be afraid. Just because the line doesn't exist in the diagram doesn't mean it doesn't exist at all. Remember the rule. For every 2 points, D and B, there exists exactly one line. So what is the intersection? Right there, point D. All right, so far so good? It's kind of hard to see. That's why I like to use Sharpies. In any case, here we go. Parallel lines is the definition. Parallel lines are two or more lines that do not intersect and are coplanar. Skew lines, this is a big one. They are lines which do not intersect and are not coplanar. So they don't intersect and they're not in the same plane. So that means they're not parallel either. And then parallel planes are planes that do not intersect. So for instance, looking at parallel lines, you can say like line X, which is right here, is parallel to line Y, which is right here. Okay, and skew could be probably this line and maybe this line. Okay, so those are two skew lines. And then parallel planes, these two planes. You can do plane A is parallel to plane B. All right, so that doesn't come out really good. What's with the lighting? Okay, example 1. Think of each segment in the figure as part of a line. Which line or planes in the figure appear to fit the description? So here we go. Lines parallel to CD. Okay, so CD, maybe if it's helpful if I point to this one. And it must contain point A. So parallel to CD would be AB. Please make sure you put that little line symbol above it. Okay, line skew to CD. Okay, it has to be in a different plane, so skew to CD would be like AE. It's a bad E. Okay, lines perpendicular to CD, remember that makes a right angle containing point A, that would be AD. Okay, so you're making a little right angle right there. And then planes parallel to EFG, okay, that's the bottom, containing point A, that would be your top plane, ABCD. Again, we only need to probably put 3 points. 3 points make a plane, but I put 4. All right, next page. Should be fairly easy. A little bit of review here. Let's go to the top. Uh-oh, another postulate. Postulate 13, parallel postulate. Okay, there is a line and a point not on the line. So let's say we have line M, and then we have a point A, not on M. There's exactly one line through that point that's parallel. Okay, so I'm going to put these little symbols here showing that they're parallel. You only actually need one little set of arrows to do that, but there's our postulate. This is actually really important. Okay, postulate 14. perpendicular postulate. This is kind of hard to see because in my picture it's green. Maybe if I turn that off. Nope, that doesn't help either. Okay, I know, we'll do our best. If there's a line and a point not on the line, so we have line M and we have point A not on the line, there's exactly one point through this line A that's going to be perpendicular. Okay? All right, so let's put these together with example 2. Now here's a little swing set. It's kind of cute. And what I'm going to do is I'm going to label some points right here. So right here, we're going to call this point A, point B, C, D, E, F, G, and then down here at the bottom of the swing, H, I, J, and K. Let's put L right here, M right here, and then N in this corner. Okay, so you might want to take your time and pause this and label it. Okay, so now, name a pair of perpendicular lines. Well, I'm going to pick DE is perpendicular. There's a symbol we're going to use for perpendicular, DH. Okay, so DE and DH. Again, there's a lot of choices here. So you can pick AB. Oh, actually, I'm sorry, I'm going parallel there. All right, name a pair of parallel lines. Okay, DE and HI are parallel. Can you see all these? I'm going to put the symbol for parallel in there. It's kind of a skinny 11. Also, you can look at AB and LM are also parallel. Is DH, okay, that's this line right here, is that perpendicular? So let me kind of stick that out. Is that perpendicular to LM? No, why not? It's skewed. All right. Angles and transversals. A transversal is a line that intersects two or more coplanar lines at different points. So say I have a set of lines here. They don't have to be parallel. There's our transversal. We'll label it T. All right, so next page, we're going to be talking about this. Almost done, almost done. All right, so here I have a set of lines, M and N, and then it's transversal to T. So now we have some very important words here. Two angles are corresponding. Here's that vocabulary I kind of warned you about. If they have corresponding positions, both above and below the lines on the same side of the transversal. Okay, so first of all, this is my transversal, and I need both above or both below. For instance, angle 3 and 7. They're both below the lines on the same side of the transversal. So angle 3 and angle 7. Those are corresponding angles. Another set would be angle 1 and angle 5. There are two more sets of corresponding angles. Can you find them? All right, alternate interior angles. If they lie between the two lines, okay, so they're going to be between these two lines. Can you see that? Probably should use Post-it notes instead. Makes it a little easier. Between these two lines, and they're on opposite sides of the transversal, and they're not linear. So that would be like angle 4 and angle 6. So look at this, 4 and 6. They're in between the two lines, and they're opposite sides of the transversal. They're not a linear pair. Linear pair means they are in a straight line. Another example would be angle 3 and angle 5. Okay, so those are the only two sets of alternate interior angles. Two angles are alternate exterior. So exterior, they're outside. I don't want to bring it too high. They're outside the parallel line, so 1, 2, 8, 7. And they're on the opposite sides of the transversal. So we have angle 1 and angle 7. Those are alternate exterior. And then also we have angle 2 and angle 8. So 2 and 8 are alternate exterior. Last but not least, consecutive interior. When I was in school, we called this same side interior. They also have a special property when the lines are parallel. But right now we're just looking at vocabulary. So same side interior, that would be like angles 4 and 5. And then also angles 3 and 6. They're on the same side. So you definitely have to know these. Okay, I have a nice worksheet for you that's in your packet that you can use, and I'll probably hang up. Okay, identify all the pairs of angles of the given type. Yes, all of them, Andrew. Okay, that was from a couple years ago. Still funny though. All right, now I'm actually not going to do all of them, so I will just pick a set. Corresponding angles. How about B and F? Okay, so here's B and here's F, so you can see that. Okay, alternate interior would be like F and D. Alternate exterior, how about B and H? And last but not least, consecutive interior or same side interior, such as A and F. So here's our assignment. There are your 2 standards. Everybody have a nice, dry Labor Day.